Stored procedures are another really popular way of implementing queries against database servers. And they're also very good at mitigating the risk of SQL injection. Now, stored procedure looks pretty much like what we see just here. We declare a procedure name, and I've called this one Get Supercars by Cylinders. We declare input parameters, and in this case I've got one called Cylinders, and it's a varchar 10, so it can only ever be 10 characters long. And then from lines 5 through 7, we can see the query which takes Cylinders as a parameter. So very simple SQL syntax here. The main thing to note is this @ syntax again, where we're passing the cylinders. Let me jump back to the web app and show you what that looks like now. I've just pasted in the code to implement this stored procedure, and there are a few more changes, but the important things I want to point out here include that we've declared the stored procedure here in my new SQL command object. I've created an explicit SQL parameter type, which is named Cylinders. It's explicitly typecast as a varchar of 10 characters long. Now that is then added to the parameters of my command. And then the remaining code simply opens a connection and enumerates through and reads the results. So that's the implementation at a code level. Let's jump over to the web app, reload the page, and then we'll take a look at SQL Profiler and see what the underlying query looks like. So here's the web app. It's still showing the result from the last clip where we implemented parameterization, which fixed the SQL injection risk for us. So let's see how the stored procedure approach works. Same end result here, so the old injection risk on that Cylinders parameter isn't happening anymore. Let's go and check out SQL Profiler. I'll jump back to the first query here in Profiler, and here we can see what's actually happening. So now we're getting an exec command on our Get Supercars by Cylinder stored procedure. And you can see that Cylinders parameter with everything nicely encapsulated in quotes. And just like what we saw when we used a parameter in the last clip, the single quote after V12 has been escaped by another single quote. So those two single quotes together effectively just represent one escaped single quote. So just like parameterization used within an inline SQL statement like we just saw earlier, calling a stored procedure with a parameter keeps segmentation between the query itself and the untrusted data from the user. So stored procedures are another great way of mitigating the risk of SQL injection. Now, one other thing to add here. Some people are of the view that a stored procedure cannot have a SQL injection risk. That's not entirely true. If you're passing a string parameter into a stored procedure, and then within the stored procedure you're concatenating a string and then calling exec, you can still have a SQL injection risk. So imagine if the code that we saw down here was actually a SQL injection payload, and then within that stored procedure, a SQL query was being built up, this untrusted data added to it, and then that resulting string executed. That would still pose a SQL injection risk. Now, it's not a very common practice, but it does happen, and it does show that stored procedures can actually still have the risk. So just be conscious that it's not entirely foolproof.